Let's look at some more problems of solving absolute value inequalities. The key, let's just look at an example first. Let's say your example is 2 absolute value of x plus 3 plus 10 greater than 38. The steps here are that the first you isolate absolute value term. The second step is you transform it into an AND problem or an OR problem. And the third step is you simply solve the different parts. So the first step here we're going to do is we're going to do minus 10 and minus 10. So you have 2x plus 3 greater than 28. And then you can divide by 2. And you get absolute value of x plus 3 is greater than 14. So that's always the first step. If you have an absolute value term, then think about drawing a circle around that absolute value term and just isolate it. Now at this point, we're going to change this into an AND or OR problem. The question is, how do we do that? Well, there's some rules, and I call them the GO-LA rules. Here's the GO-LA rules. First, if it's absolute value of x greater than a number, it can also be greater or equal to, either way, then this makes this into an OR problem. That means x is less than minus 10 or x is greater than 10. If it's a less than problem, so if it's like absolute value of x is less than 5, we can also do it with less than or equal to 5. Less than becomes an AND problem, so that means it's between minus 5 and 5. And if you want to do the greater than or equal, it would be the same. So now if we come back to this problem, apply these rules, come back to our problem here, we have x plus 3, absolute value of x plus 3 is greater than 14, so is this an AND or an OR problem? It's greater or G-O-L-A, greater or less and. So it's a greater is OR, that means it's going to be less than the negative, or greater than the positive. Now we simply solve both of these. You subtract 3 and subtract 3, and you get x is less than minus 17. Or, here you're going to subtract 3 and subtract 3, x is greater than 11. Let's do one quick example, and then let's look at some potential trick problems. Let's do 4 minus absolute value of x plus 3 is less than or equal to, let's do 1. First thing you do is you're going to subtract 4 and subtract 4, and you get minus absolute value of x plus 3, less than or equal to minus 3. Now you're going to divide by a minus 1, and divide by a minus 1, and you get absolute value of x plus 3, and that's going to be a positive 3. Now here you have to be careful here. Remember the sign flipping rule. Whenever you have a linear inequality, and you divide both sides by a negative, and the sign is going to flip. So this is less than or equal to, that becomes a greater than or equal to problem. So that's how you isolate the absolute value term. Then you make it into either an or an and problem. This is greater, greater, or less and. Greater or less and. Greater than is going to be an or problem. So that's x plus 3 is less than or equal to minus 3. Or x plus 3 is greater than or equal to 3. And you simply solve both of these. That's x is less than or equal to minus 6, or I think that becomes 0. Subtract 3 from both sides, it becomes 0. X is greater than or equal to 0. So your answer is x is less than or equal to minus 6, or x is greater than or equal to 0. So what about trig problems here? There's two potential trig problems here, and that is that we are either going to have an absolute value term which is going to be less than or equal to a negative. Absolute value term can't be less than a negative. If it can't be less than a negative, then that means there's no real solution. The other possibility is you have it greater than a negative. When is an absolute value greater than a negative? Well, an absolute value term is always going to be greater. It's always going to be positive, so it's always greater than negative, so that's going to be all real numbers. So anytime you get to a problem where you get to this point or this point, you know it's a trig problem, and you know the answer is either no real solution or all real numbers. And there's a follow-up video if you want to see more on this called Absolute Value Inequalities Trig Problems.